Hi class, it's Mrs. Kane and I'm here with your next e-learning lesson. We're going to move on from simplifying rational expressions, and today we're going to start talking about solving rational equations, and this will be the last new topic for Unit 7. So it's a 2-day topic, and it will culminate in a quiz over solving and then your Unit 7 test. So we're going to start today by talking about the first method that we're going to learn to use to solve, which is cross multiplication and division. Okay, and that expression should sound familiar. I'm just going to kind of review where it comes from and how it works. So we're going to start with a quick little introduction, and it says to write each fraction in reduced form. So if you know how to do that, go ahead and pause the video and reduce these 3 fractions. Okay, if you need a refresher, go ahead and stay with me. So to reduce 3 over 9, we look for a common factor. So 3 and 9 are both divisible by 3. And so we divide the top and bottom by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. And so we know that 3 9ths equals 1/3. For number 2, we have 10 over 12. So we can divide the top and bottom by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. And so 10/12 equals 5 over 6. And then lastly, 6 9ths. 6 and 9 are both divisible by 3. So if we divide by 3, 6 divided by 3 is 2. 9 divided by 3 is 3. And so 6 9ths equals 2/3. Okay, so it says, now look at the diagonals formed by the original fraction. That should say now, not no. So sorry about that. Now look at the diagonals formed by the original fraction and its reduced form. And what do you notice? Okay, so this question is asking you to look at your diagonals, 9 and 1, and then 3 and 3. And it says, what do you notice? So maybe pause the video and see if there's anything significant that you notice. Okay, and so what I want you to notice here is that 9 times 1 is equal to 3 times 3. 9 times 1 is 9. 3 times 3 is 9. Okay, and if we check that in the next equation called the proportion, is 12 times 5 equal to 10 times 6? Well, 12 times 5 is 60 and 10 times 6 is 60. So yes, those cross products are equal. Okay, and then if we try the last one here, we've got, if we cross multiply 9 times 2, is that equal to 6 times 3? Well, 9 times 2 is 18 and 6 times 3 is 18, and so yes. Okay, so we call these equal fractions. It's called a proportion. Okay, so when you have a single fraction equal to another single fraction, we say the cross products are the same. So in general, if we have this proportion here, A over B equals C over D, okay, what we just kind of found or reviewed is that A times D is equal to B times C. And the order does not matter, so you could also think of it as B times C equals A times D. Okay, so we're going to use this idea of cross multiplication to solve some rational equations. Now, one thing you have to be careful of with rationals, and it won't come up very much in our notes, but I want to at least point it out, is that when you have a variable in a denominator and you're trying to solve, you have to make sure that whatever your answer is for x or n or v or whatever it happens to be does not cause your denominator to be 0. So for example, in this first problem, if I solve and I get x equals 0, that's called an extraneous solution because we're not allowed to divide by 0. Okay, so I just want to, again, point that word out. We might see 1 or 2 examples with an extraneous solution. Always just kind of do a quick check to make sure that your answer does not cause a problem in the denominator. All right, so in the problems we talk about today, you're going to notice that you have proportions. We're solving proportions. And so we are going to use cross multiplication to solve. So in this case, what we just found is that x times 9 equals 3 times 12. X times 9 equals 3 times 12. Now, we don't usually write x times 9. So instead, I'm going to write that as 9x. And 3 times 12 is 36. Okay, and notice that allows us to easily solve for x. And so we get x equals 4. Now, before I highlight my answer, I'm going to do a quick check at the original problem. And notice if x is 4, you get 3/4 equals 9/12. So that's not only true, but it does not cause division by 0. Okay, so for the next problem, let's go ahead and cross multiply. What you have to notice on this one is that we have 2 terms in our first denominator, x minus 1. I'm not sure why this changed color on me, sorry. I'm going to put that back. So we have to multiply 3 times x minus 1. So if you have to multiply a single number and an expression, you got to make sure you put that x minus 1 in parentheses. So for this problem, 3 times x minus 1 equals 6 times 5. And now we have to distribute that 3. So we get 3x minus 3 equals 6 times 5 is 30. And then we can add 3 to get 33 and divide by 3. 33 divided by 3 is 11. And notice if I put 11 in for x, I get 6 over 10 equals 3 over 5, which is true. And I don't have any division by 0, so I'm going to go ahead and highlight my answer. Okay, so if that makes sense, go ahead and pause the video and try the next one. Okay, otherwise I'll go ahead and do one more with you. So again, this time we're going to cross multiply. We have 2 times 2x plus 3, and that's going to equal 5 times 4. So 2 parentheses, 2x plus 3, that reminds me to distribute, equals 5 times 4 is 20. Okay, I'm going to go ahead and distribute to get 4x plus 6 equals 20. And then I'm going to subtract 6 from both sides. 4x is 14. And then divide both sides by 4. And I can reduce this fraction. 14 over 4 is 7 over 2. Okay, and notice if I put 7 halves there, I'm not going to get a 0 on the bottom. 2 times 7 halves plus 3 does not equal 0. Okay, and so my answer is 7 halves. I'm going to go ahead and highlight my answer. Okay? All right, so we're going to bump our problems up just one little notch. And what you're going to notice is different in the next set of examples is that we are going to have variables on both sides of our equation. And we're going to have to distribute twice. Okay, so notice in this next example, we have to multiply. We know these cross products are the same. We have a fraction equal to a fraction. And so we need to multiply. I'm going to put the 2. I always like the whole number in front. So 2 times the expression x plus 5 equals 3 times the expression x minus 3. Okay, and again, the order in which you write your diagonals is not important. Okay, but notice I have to distribute twice here. I get 2x plus 10 equals 3x minus 9. And then I'm going to subtract 2x from both sides because I like to keep my x's positive. I get 10 equals x minus 9. And then the last step is to add 9 to both sides, and I get x equals 19. Okay, and notice 19 minus 3 is 16, so I don't have an extraneous solution, so my answer is just x equals 19. I'm going to go ahead and highlight that. All right, go ahead and try the next one. Pause the video, try the next one. All right, and then if you want to stick with me or if you're checking your answers here, you're going to multiply 2 times 3x minus 1 to equal 4 times x plus 2. And then when we distribute, we get 6x minus 2 equals 4x plus 8. And then I'm going to subtract 4x from both sides to get 2x minus 2 equals 8. And then I'm going to add 2 to get 2x equals 10. Divide by 2, x is 5. Check to make sure you don't get zeros on the bottom. 5 plus 2 is 7. 15 minus 1 is 14, so we're good. And so we highlight our answer, x equals 5. All right, so just cross multiplying and then adding in the algebraic steps to solve. Now, the last set of problems are a little bit more challenging, okay, but I want you to go ahead and try these with you. Most of you are pretty good at factoring. Okay, so what we're going to notice in these last two problems is that after we cross multiply, we're going to have an x squared, an x, and a constant, and so we're going to have to set it equal to 0 and solve by factoring. So if I cross multiply in this next example, I have x times x minus 1 equals 3 times 4 is 12. Now when I distribute, x times x is x squared minus x equals 12. Okay, and right here I want you to recognize this as a quadratic. And so if we want to solve this quadratic, we need to set it equal to 0. Okay, so now if we want to factor, we need two numbers that multiply to negative 12 and add to negative 1. And so we can use negative 4 and positive 3. And so we get x minus 4 times x plus 3 equals 0. And so if x minus 4 is 0, x is 4. And if x plus 3 is 0, x is negative 3. Okay, and do a quick check. If I look at my denominators, I have an x in the bottom, so 4 works and negative 3 works. Okay, so again, I'm not really going to give you problems with extraneous solutions. I just want you to understand what they are. Or actually, I think the next one might have one, so that would be a good example. All right, so let's do one more of these where we have to factor. So this time when we cross multiply, we have 1 times x squared plus 4x equals 3 times x plus 4. Okay, on the left side, when I distribute 1, I just get x squared plus 4x. And on the right side, I get 3x plus 12. And because I have an x squared, I have a couple constants, and I have a 12. That tells me to set everything equal to 0. So I'm going to subtract 3x. I'm also going to subtract 12. And notice that doesn't have anything to go with on the left side. So we get x squared plus x minus 12 equals 0. And then I'm going to factor. I need two numbers this time that multiply to negative 12 and add a positive 1. So I get 4 and negative 3. And so if I factor that to x plus 4 times x minus 3, if x plus 4 is 0, x is negative 4. And if x minus 3 is 0, x is 3. Okay, and here's your example of an extraneous solution. If I put negative 4, check the second denominator. If x is negative 4, you're going to get 1 divided by 0. Okay, so this is an example of an extraneous solution. We cross it out. We cannot have an answer that causes the bottom to be 0. Okay, but if x is 3, the right side is going to give me 1/7, and then the left side will be 3 divided by 3 squared is 9 plus 12. Okay, and so that answer is fine. And so even though our factoring produces two answers, only one of them works. All right, so that's how we solve using cross multiplication.